So we said before that some isotopes are unstable. By that we mean that the nucleus will not stay the way it is. At some point in the future, it's going to decay or disintegrate, and in doing so, it changes into something else and emits some form of radiation. And as far as you're concerned, there are three types of radiation that it can emit, named after the first three letters of the Greek alphabet. Okay, so alpha, beta, gamma. And the next three videos on here will look at those three different types of radiation. So the first type we're going to look at is alpha. Okay, alpha is a little symbol like this. Um, and what it consists of is two protons and two neutrons. And as long as we know what it's made of, we can work out all the other properties about it, okay? Because we want to know its relative atomic mass. Well, each proton has a relative atomic mass of 1. Each neutron has a relative atomic mass of 1. So if it's two protons and two neutrons, its relative atomic mass is going to be 4. Its charge, well, it contains two protons and two neutrons. Each proton has a charge of +1, so that will be +2. And the two neutrons, well, neutrons are neutral, so they have 0. So the overall charge is +2. Now, we have some other key properties that we look at for each of these. One of those is the ability of that radiation to ionize. Now, by that we mean, let's say we have a carbon atom. Okay, so carbon is normal isotope is carbon 12, which just means it will have a nucleus that contains 6 protons and 6 neutrons, and will have as an atom the same number of electrons as protons, so that's 6 in total. Okay, now let's say we have our wee alpha particle that has been ejected by another nucleus somewhere off screen. Okay, so this is our alpha particle. Now it has a charge of 2, and what that means is it will affect other charged particles. So as our alpha particle goes by here, the electrons will feel force from it. And what it can cause to happen is it can cause an electron to be ejected. Okay, so our alpha particle will head on its way and will have essentially knocked an electron out from that atom. Okay, now that atom then used to have 6 protons, 6 neutrons, and 6 electrons, which meant before this occurred, it has a charge of +6, 0, -6, overall charge like every atom, nothing. Okay, it's neutral. However, it has now lost an electron, which means that now it has a charge of -5 from the electrons, +6 still from the protons because they haven't changed, which means overall it now has a charge of +1. And we call atoms that have become charged ions. So this alpha particle has made this atom into an ion just by passing it by. And that's what we mean when we talk about its ability to ionize, its ability to make ions. Because alpha has a charge of +2, the electrons that it passes by will feel quite a large force from that. Also, the alpha particle is quite heavy, so it has a lot of momentum. So it does mean it can knock a lot of electrons out of the way. Okay, it's a bit like a bowling ball hitting into pins. Okay, so it's got a high ionization ability, but a low penetration ability. By that we mean it's the ability of the type of radiation to pass through materials. Because the alpha particle has a large charge, it interacts with matter quite a lot, and that matter will eventually slow it down. So the alpha particle can be stopped by about 2 centimeters of air or even a piece of paper. Okay, so it's very, very lowly penetrating. Now, if a type of radiation has an ability to ionize, that makes it dangerous, and it makes it dangerous to humans because When your DNA is replicating itself, it unravels from its double helix. If you ionize a little part, a little bit of that code, um, when that DNA copies, it might not copy correctly. Okay, so you get a little bit of a mutation, and this ionizing ability can cause that to happen. Mutations can lead to cancers, which is what makes this dangerous. However, alpha is therefore dangerous because of its ability to ionize, but its ability to penetrate is low, which means if you have a source of alpha in your house, which almost everyone will have because it's in your smoke alarms, you don't have to worry about it, because even though it's emitting alpha particles, the plastic casing will stop it, and the layer of air there is between your smoke alarm and the top of your head is more than enough to completely stop those alpha particles. Okay, so in summary, alpha, 2 protons, 2 neutrons, relative atomic mass of 4. Remember, the atomic number here is the number of protons, so it'll be 2. So sometimes we write alpha as 2, 4, but sometimes we actually just use the symbol He for helium, because alpha particle, though it's not a helium atom, it has the same nucleus, so sometimes we use that symbol instead. I'll tend to stick with this one, but if you see this in past papers, don't worry too much, it does mean the same thing. Because it has a large charge, it has a high ionizing ability, but also because of that, that makes it lowly penetrating. So it will be absorbed by 2 centimeters of air or a sheet of paper.